Dear student, welcome back. In our last class, we learned certain numerical related to Kirchhoff's loop rule and resistance of a material of a wire, and by using that we calculate current that we learned in our last video. And today we are going to discuss new set of numerical that is related to Wheatstone bridge. Then we start with the new set of numerical now. The question number 4, the Wheatstone bridge circuit have the resistances in various arms as shown in the diagram of figure. Calculate the current through the galvanometer. Dear student, in case of this question, they provide the circuit. That circuit we call it as Wheatstone network or Wheatstone bridge. Here 4 resistors are connected in a cyclic order in the form of quadrilateral. I clearly said in theory itself, this Wheatstone bridge or network containing 4 corners, and out of that 4 corner, in between corner A and C, they connected cell of suitable EMF. They given internal resistance is not mentioned. Automatically you have to take internal resistance of this cell is equal to 0. You have to skip. Internal resistance is negligible. And again remaining to corner B and D, in between that they connected galvanometer of resistance 15 ohm. In case of this numerical, our requirement, you have to calculate the current through the galvanometer. Galvanometer ಎಷ್ಟು current flow ಆಗ್ತಾ ಇದೆ, that you have to calculate. And remember, if this kind of questions are given, and first you have to check whether the circuit is balanced or not, is important one. If the circuit is balanced, that is nothing but P by Q is equal to R by S ಆಗಿದ್ರೆ automatically current flowing through a galvanometer ಏನಾಗಿರುತ್ತೆ, 0 ಆಗಿರುತ್ತೆ. Automatically no need to calculate, no need to do the further calculation. Current flowing through a galvanometer itself is equal to 0. That's why first you have to check P by Q is nothing but R1 by R2 is equal to R by S is nothing but R3 by R4. Whether the circuit is balanced or not, you have to check. One ವೇಳೆ balance ಆಗಿದ್ರೆ, you will learn theory very well. The current flowing through a galvanometer will become 0. And think, here P is equal to 100, Q is equal to 10. 100 divided by 10, that condition like this. P divided by Q is equal to R divided by S, where P is equal to, what is that here, 100. Q is equal to 10. Q is equal to 10. Is equal to, R is equal to 60. And again, S is equal to how much given here? 5. Again here 1 0 and a 0 gets cancelled. This side I got 10. Another side 5 1s are 5 1s are. Again here is also 1. Again remaining is what? 1 is remaining, 10, and 10 is nothing but 2. Here I got a 10. And the side I got a 12. Is it 10 is equal to 12? No. Here P by Q not equal to R by S. If P by Q not equal to R by S, condition says that current flowing through a galvanometer not equal to 0. Current flowing through a galvanometer not equal to 0. That's why we have to calculate the current flowing through a galvanometer now. And again in a given circuit, this cell provide energy. Current drawn from the cell, I will take it like this, is a current drawn from the cell, and whatever current drawn from the cell reach to a node A. Node A ge baratte. At a node A is divided 2 branches. One is current I1 and the one is current I2. Here I1 and I2 are the 2 branch current. It is divided into 2 parts at a node or junction A. Automatically you learn the junction rule. Current entering to the node is equal to sum of current leaving the node, or sum of current entering the node is equal to sum of current leaving the node. Here sum of the current entering the node, I take an arrow mark like this. Sum of the current leaving is nothing but I1 and I2, is nothing but I1 plus I2. Here sum of current entering is equal to sum of current leaving. That's why this term becomes I1 plus I2. And I1 plus I2 entering to the junction A is divided to 2 branch. One branch is I1 current flowing through 100 ohm, and the branch is I2 current flowing through 60 ohm. this I1 current reached to this particular point B is also act like a junction, and in a junction this current becomes IG. IG is the current flowing through a galvanometer. Out of I1 current, IG current is leaving, remaining current becomes I1 minus IG. You already learned this. Simple logic. ಇಲ್ಲಿ I1 ಕರೆಂಟ್ ನೋಡ್ ಆರ್ ಜಂಕ್ಷನ್ ಬಿ ಗೆ ಎಂಟರ್ ಆಗಿದೆ, ಅದರಲ್ಲಿ IG ಕರೆಂಟ್ ಹೊರಗಡೆ ಬಂದ್ರೆ ದ ರಿಮೈನಿಂಗ್ ಕರೆಂಟ್ ಈಸ್ I1 minus IG. Just imagine 10 amps entered, out of that 2 amps leaving, remaining is 10 minus 2 is nothing but 8 amps. Same way, I1 is entered, IG is leaving. In this branch, current becomes I1 minus IG. And here I2 is entering to a junction D, IG is entering to a junction D. Sum of the current entering to a junction is equal to sum of the current leaving the junction. Automatically along this line DC, current becomes I2 plus IG, I2 plus IG. Here I2 plus IG is the current flowing in this branch. Here I2 plus IG entering to this junction, I1 minus IG entering to this junction, and IG and IG gets cancelled. Remaining here it becomes I1 plus I2. This one is a simple way of explanation of circuit while dividing the current in a junction. Is that clear? Yes. Once you get this circuit, you have to apply the Kirchhoff's loop rule. By applying the Kirchhoff's loop rule, you have to get the value for current flowing through a galvanometer IG. It is our requirement. Calculate the current through galvanometer. Ili tanaka artha aitalva? This circuit analysis is very much important. Once you got the clear idea about circuit analysis, then you can easily find out the current flowing through galvanometer by using Kirchhoff's loop rule. Dear student, here I already named the 4 corner ABCD. Again, for our loop selection purpose, I indicate this one is E, this one is F. These 2 corners are called E and F. And again, by using Kirchhoff's loop rule, you have to get the equation. First, apply Kirchhoff's loop rule to the loop. A, B, D, A. ABDA. To the loop ABDA. If I consider loop ABDA like this, I am moving from A to B. The direction of current is along my path. In the last video I already said, along my path you have to take negative. Automatically current is I1, resistance is 100. It becomes minus 100 I1. Next, I am moving from B to D. Current is along my path, IG is along my path. It becomes 15 IG, where 15 is the resistance of the galvanometer. It becomes minus 15 IG. Next, I am moving from D to A. Here direction of current I2 opposite to my path. Then you have to take plus. It becomes 60 I2. It becomes plus 60 I2 is equal to, what is that? 0. Because no cell is here, automatically is equal to 0. And I got this equation. Simplify further. Here all the term is divisible by using 5. And again you can easily get the answer. Here it becomes minus 10 I1 divisible by 5 here, minus 10 I1 minus 3 IG. Here it becomes plus divisible by 5, 12 I2 is equal to 0. I call this as equation number 1. By considering loop ABDA. Similarly, apply Kirchhoff's loop rule to the loop BCDB. Apply Kirchhoff's loop rule to the loop BCDB is the loop. I am moving from B to C. Direction of current I1 minus Ig along my path. Automatically it is plus or minus? Minus 10 into I1 minus Ig. This one is completed. I am moving from C to D. I2 plus Ig is the current. This direction of current is opposite to my path. Then it becomes plus. It becomes 5 into I2 plus Ig. Then I am moving from D to B. Ig is the direction of current. Here it is along my path or opposite to my path. It is opposite to my path. Then you have to take plus 15 Ig is equal to 0. Rearrange this. Again here minus 10 into I1. Again minus into minus becomes plus here. 10 Ig here it is 5 Ig, here it is 15 Ig. Total becomes 10 Ig plus 5 Ig, it becomes 15 Ig plus 15 Ig, it becomes 30 Ig. Again remaining is 5 I2 plus 5 I2 is equal to 0. Once I got this equation, I assume that this one is the equation 2. Dear student, by solving equation 1 and 2, you have to cancel either I1 or I2. It is simple addition or subtraction method. Here, equation 1 is like this. Minus 10 I1 minus 3 Ig plus 12 I2 is equal to 0. Equation 2 is like this. Minus 10 I1 plus 30 Ig plus 5 I2 is equal to 0. By using these two equations, I will go for method called subtraction. During subtraction, this minus becomes plus, this plus becomes minus, this plus becomes minus. Automatically minus and plus, 10 I1, these two gets cancelled. Here minus, these two get added, it becomes minus 33 Ig. Here plus 12 minus 5, and these two subtracted, it becomes plus 7 I2 is equal to 0. Plus 7 I2 is equal to 0. I call this one as a equation number 3. And up to here I got here minus 33 Ig plus 7 I2 is equal to 0, equation number 3. Then you have to think about one more loop. For that loop also you have to apply the Kirchhoff's loop rule. Next step, apply Kirchhoff's loop rule to the loop. Apply Kirchhoff's loop rule to the loop ADC EFA. It becomes A to D, D to C, C to E, E to F, F to A. Now this loop you have to count. And if I move from A to D, here I2 current along my path, it becomes minus 60 I2, and again D to C, I2 plus Ig along my path, it becomes minus 5 I2 plus Ig. Again I'm moving from C to E, nothing is there. E to F, here internal resistance is 0, no need to think about resistance part. Here I am moving from E to F, second terminal of the cell is positive, automatically it becomes plus 10. Again I am moving from F to A, nothing is there. That should be equal to, what is that? 0. On simplification it becomes minus 60 I2 minus 5 I2, it becomes minus 65 I2, again minus 5 Ig is equal to minus 10 if I take 10 to that side. Again this is divisible by 5. Again we can easily simplify like this. It becomes Ig if I divide by 5, again plus 65 divided by 5, it becomes 13 I2 that should be equal to, what is that here, minus 2. It is that multiplied by minus also it becomes 2. I call this one as equation number 4. Dear student, here I got two equation. One, equation number 3, minus 33ig plus 7i2 is equal to 0, and second equation is ig plus 13i2 is equal to 2. We call it as equation number 4. Simplify 3 and 4 in such a way that you have to cancel i2. We can easily get the answer for ig. Right. And you have to simplify that equation 3 and 4 in such a way that you have to multiply certain term here to cancel the i2. Here 7i2 is there where 13i2 is there. Then multiply 13 to 3. Multiply 7 to equation 4. In these two equations, i2 gets easily cancelled. Then equation 4 into 7. Equation 4 into 7 gives 7ig plus 7 into 13, it becomes 91i2 is equal to 7 into 2, it becomes 14. Similarly, equation 3 into 13 gives, equation 3 into 13 gives, here equation 3 into 13, when you're going to multiply 13 into this equation, 33 into 13, it becomes 429 ig, 429 ig, plus 7 into 13, it becomes 91 i2 as it is. 13 into 0 is 0, and you have to work out these two equations in such a way that I want to cancel i2 term. Again, subtract these two equations. When I'm going to subtract these two equations, dear student, here it is minus, here it becomes plus, because here minus 33 into ig is there. When I'm going to multiply 13, minus 33 into 13 becomes 429 ig minus, and again 13 into 7 becomes 91 i2. Here we have to subtract, this becomes plus, this becomes minus, and again these two terms gets cancelled. Once these two terms gets cancelled, remaining is these two is added here. 9 plus 7, it becomes 16. 1 is remaining, it becomes 3. Again 4 as it is. 436 ig is equal to, these two gets cancelled here. Remaining is 14 minus 0 is 14 itself. Simplify further, ig is equal to 14 divided by 436. On simplifying further, we got the current flowing through a galvanometer is equal to 14 divided by 436 is 0.00487, and unit for current is ampere. And again we can write this one as current flowing through a galvanometer is equal to 4.87 milliampere is a value for current flowing through galvanometer. Is that clear? Right. Dear student, sometime they're going to ask the question, this kind of question in the annual exam for 5 marks is a way to simplify Wheatstone bridge. And again we can go for alternate method also. These kind of substitution methods you learn in maths, you can go for alternate method also. That all you can easily get the answer for current flowing through a galvanometer. Right. Up to here we'll wind up the current electricity chapter. In the next class we start with the new concept or new chapter and go through all the things what is there in current electricity. I will give a notes for current electricity in your group and check that, and remaining thing we'll discuss in next class. Thank you.